This is an AI-generated image, which is pretty cool. If you guys have ever played with Midjourney, it's a lot of fun. But this is not an AI-generated image. That's me, my wife, and my 3 kids. I wanted to put that up front and center because, like, we're all humans. We're all part of this kind of tech thing, and we just become little Twitter bubbles, but I'm a real person. I work at a company called Braid. I'm a founder there, and then these are the open source projects that I maintain. So if you guys are Vue users, you may have used Vue Formulate back in the Vue 2 days, long time ago. FormKit is the successor to that. We basically make building forms in Vue really easy, really complex forms in Vue really easy. And AutoAnimate is this super cool little one function that lets you animate DOM transitions on your page. But I'm not going to really talk about any of that today. I am going to talk about modern JavaScript, and this is not where we started. I started writing websites when this was my browser. So that's Internet Explorer 5 for Macintosh. Anybody go back that far? Yeah, all right. This is really exciting because it was one of the first browsers to ship with CSS support. And that was, I remember coming home and sitting down one summer and saying, I'm going to learn this CSS thing. And that's what I've been doing. That's actually a shot of me doing that. All right. So Corey House has a great quote back from 2017. Why are you here? I've shown this in a lot of talks, and he's here, so that makes it fun. After attending many conferences, I've learned I do not attend to learn. I attend to learn what I need to learn. So the question is, what are we going to try to learn today? So we're going to learn 4 underutilized techniques and patterns. The talk is called Design Patterns. If you're here thinking we're going to talk about Figma or some kind of design, this is the wrong place for you. We're talking about JavaScript design patterns. This is really important. So Matt Brophy had a great talk about remix, and the fundamental ideas here are we want things to be compliant with the platform. So what is the platform? Well, ultimately, it's the fundamentals of JavaScript. Things that maybe we skipped when we were learning because we just started learning React or we started learning something else, and we kind of forgot that under the hood, this is an entire language. I mean, here's Steph Curry sinking a bunch of threes, and I guarantee you his coaches all along the way preached to him over and over again about the fundamentals. It wasn't enough to know how to shoot the basketball. You had to be an expert at the fundamentals. So that's what we want to do. So what are we going to learn? We're going to talk about module scopes, module scoping. How do variables and functions exist within the scope of a JavaScript module, specifically an ESM, ES6 module. So we're going to do that by talking through the concept of a shopping cart and doing it kind of interactively that way. We're going to talk about weak maps. So what are weak maps? Well, we're gonna go through that. Anybody here using weak maps on a regular basis? All right, we got one person using a weak map. This has been in the spec and published for over 7 years, I think, at this point. Well supported and not well understood. So we're going to talk a little bit about that. We're going to talk about proxies. Show of hands for proxies. Okay, a little bit more. These things are amazing. They're incredible. We're going to talk about it and how you might be able to do some form validation with it. And then we're going to talk about tagged template literals. I hope everybody would raise their hands if we talked about template literals, right? $, curly braces, put your stuff in there. Tagged template literals are part of the same spec and really, really underutilized. So that's what we're going to go through today. This is absolutely going to be drinking from a fire hose. But remember, you're here to learn what to learn, not necessarily to learn. So it's okay, all right? It's okay. First, let's look at the browser compatibility. ESM, or ECMAScript 2015 is when this was introduced. We're good to go here, right? I mean, you even got some IE11 support at this point. Hopefully, you guys have been able to push IE11 to the curb, but if you haven't yet, you will soon. In this case, you're even good to go for IE11. So the key concept to understand about module scopes, and now this is going to be me giving a little bit of opinion, with a little bit of what is actually happening under the hood. Your module scope is ideal for global state. Ideal for global state. Let's talk about that. Pop quiz. All right, here's what we're going to do. I've got 5 questions. 1, 2, 3, 4, 5. We're going to walk through a tiny snippet of code, and then in your mind, I want you to guess what the output of this code is going to be. You have 5 seconds on each of these after we talk through it. First one. Here we've got 2 script tags. We have const cart with a little array, and we're console logging it in a different script. Okay? Here's your time. Think it through. All right. Makes sense. Not a trick question, right? When we created const cart on the first one, that was in the global scope. It was in the window scope or your global one. All right, next one. We got a function this time, cart. It has an array inside of it that's being returned immediately. Down below here, we are asking for that array, and then we're pushing pair onto it. And then finally, we're going to console log that call to cart. All right, here's your 5 seconds. If you guess that nothing happened, you are right. Each time we called that function, it was a new scope inside of cart, and so we never actually made any modifications. All right, now we're talking about module scope. So we've introduced this slightly new layer. Here we have the same 2 script tags, but both of them are now type module. So this is identical to our previous one. We've just added the little type module. We create a cart, and then in another module, we console log the cart. All right, here we go, 5 seconds. Interesting. Okay, our variable is undefined. Well, it's not just undefined, it literally doesn't exist. And that is because inside of each of those module scopes, they have their own scoping. So you create a variable in one module, it is not available in another module. All right, second to last one here. Here we have a type module. We are adding apples and oranges to the window.cart, okay? And then in a non-module, console logging out the window and cart.cart. All right. I'm going to be really impressed if you guys get this one. This one is undefined. It's a trick question. It's undefined because in JavaScript, modules are deferred automatically. So this is actually a timing problem here. You ran the second piece of code before the first one ever ran. And so it was undefined, even though we were making a modification on the module scope. If these were both type module, it would work a treat. All right, now this is how we usually use modules, right? We've got 2 files. We have a cart file, and now we've got our actual HTML file. We are exporting a function that is referencing cart. Cart is just a const inside of that module. And then where we're using it, we're importing that function. We're calling the function. We're pushing pair on. This looks familiar, right? And then at the end, we console log the cart. Okay, here's our 5 seconds, last question. Interesting. We modified the value. Now we modified the value because what was returned to us was an object in that module scope, and down here we were able to mutate the value in the other module scope. Very interesting. How could we leverage that? Let's review like what we just picked out from this quiz. So first of all, it's important to understand that module scope does not pollute the global scope. Now we could have done everything that we just talked about. You could have a global store available to you at any time, and you can do that by just putting literally everything on the window object. We've learned over time that that's a bad idea, and so we don't do that. So global or module scopes are great because they don't pollute that global scope. They're kind of like an entire universe of little self-contained bubbles, right? And each one of them is indistinguishable from the other. They have no communication unless we explicitly create that communication. They persist for the entire runtime. This is often missed. When we created that cart and we imported it into that HTML file in that quiz, we could have imported it into another script or another location, and our added value would have been there as well. And this enables you to do access control for your data. So let's talk about that a little bit. How could we create a data store using nothing but native JavaScript? So we're not using Redux here, we're not using Vuex or Pina, or I don't know what the hot flavor is in React these days, but this is just going to be straight up JavaScript. Okay, we've got a little bookstore here, and we have our index.html file. All I'm really interested to talk to you about is the button. All right, we've got a button in here, add to cart. So we're talking about all those add to cart buttons. All right, we get that listed out on the page, and now we have a type module script on that page, and we're importing an add to cart from some module that we're calling cart.mjs. You could call it .js. The M is sort of there's a lot of hot debate about it. And now we're going to add an event listener, and we're going to listen to all the button clicks on the entire site, clicking anywhere on the site. But if the attribute that we click on, if the element we click on has the data attribute product, then we're going to go fetch some product from this get product function, where details left to your imagination, and we're going to add something to the cart. So what I'm interested in is that add to cart feature. What does this cart.mjs file do? All it is an array, const cart. It's just an empty array. That's our cart. Then we have a function called add to cart. And all it does is push a value onto that cart. Pretty simple. Now, the cool thing is that from our index file, there is no way to modify that cart variable. It's impossible. You cannot get access to it. You cannot modify it. Except for that we exported this one little function, and now we have access control around a variable in JavaScript. And remember, it's persistent. So we can pull cart data, theoretically, if we provide a way to do it, from any other location in our app. So if we click on this 3 times, well, nothing happens. That's unfortunate. Let's do something about that. So here we have we've modulified that code. Now we've got 2 modules. A little easier to look at this instead of an HTML file. But it's the exact same thing. We're importing add to cart, we're listening to clicks, and we're doing something about it. Now that little cart up there, it'd be awful nice, wouldn't it, if when you click add to cart, something happened up there. We're not using React though, so how are we going to do this? Well, first we'll just go ahead and do the old school get element by ID. We'll get that element up there. And then we want to put the total number of items in our cart somewhere around that. So we'll create a method for it, or a function for it, over in our module, our cart module. We'll import that in our second module. And then at that point, all we really need to do is add, there we go, a little badge. So we're going to use old-fashioned JavaScript here. We're going to create an element. We're going to attach it. We're going to set a data attribute count. This is just a little cheating. So we'll do something like that in CSS, where we take the data attribute value and we render that as the pseudo element. Don't worry about that. That just makes the number show up. So there it is. Now we have a number. Awesome. Let's click the button. Oh no, nothing's happening. Of course nothing's happening. We haven't added any reactivity. This isn't React. So back in our original one, let's add something called handlers. This is just another module scoped variable. And inside of here, we are going to put a little onChange method function. We're going to import onChange into our primary one. Oh yeah, right there, add to cart. Anytime something gets added to cart, we're now going to call all the functions that are in that handler. So here we go. We're importing onChange into our second file. And then whenever a change happens, we're going to just change the data attribute. Okay? Now we are actually incrementing that number over there. 1, 2, 3. Awesome. Let's throw a little fancy CSS on there. I know a lot of people don't use that old technology CSS these days, but there it is. 1, 2, 3, okay? And now we've got a little cart badge on there. All of our data is in the store. You can imagine you could very easily repopulate this store with something as simple as a cookie. And now you've created a global state, global store available anywhere in your application very, very easily. That little demo is actually available. You can go click around with it. You can get the source code for it if you want. It's actually a little more advanced if you go there. So I'll leave this up on the screen for like a couple seconds if somebody wants to take a picture of it or something. And then we're going to move on. That was module scopes. They let you create variables and data inside of a module that's protected. You can control the access to it. Let's talk about weak maps. I love weak maps. I love weak maps. I love weak sets. There's actually something called a weak ref. These are kissing cousins to maps and sets, if you guys are familiar with those. Let's take a look at this. Compatibility, we're good. We're very good, actually, in this case. You can use these very, very, very safely. What's the key concept here? You use weak maps to attach data you own to data you don't. We'll unpack that a little bit more. Now, of course, there's other use cases. This is where some of my opinion is coming in, but you use weak maps to attach data you own to data you don't. Okay, let's talk first just about a plain old map. What is a map? Okay, what we've got here in this source code is what we would call an object literal, where we have an object with some string keys, item 1, item 2, and those are related to some data. Okay, wouldn't it be cool if you could get 2 elements off the DOM and then say something about them, element 1 and element 2? That would be awesome. That does not work. You cannot use that there because in this case, an object literal will always have string keys. So what you just created was a position with a EL and an EL2 property. But what you can do is you can create a map. And maps are incredible. You can add to the map the element as the key. And then the value that you add on the other side can be whatever you want. So this is a great way to attach data to something like a DOM element. There is, however, a slight problem with this. When you do this, you just created a memory leak. And you created a memory leak because that DOM element that you just referenced cannot be garbage collected anymore. So if somebody removes it from the DOM, which is likely to happen in something like React or Vue, it will actually always continue to exist in memory. So this is a problem, and this is why weak map exists. Weak map is the solution to this. It lets you do a reference to something that you don't own that can be garbage collected in the future. So we don't need to think about the details of garbage collection, but if you want to say something about another element or any kind of object, you can do this with an object literal, you can do it with anything. I think DOM elements are super convenient, but you can do it with all kinds of stuff. Use a weak map. So what do we mean by use weak maps to attach data you own to data you don't? Well, on the code on the left here, we've got const foo, this is my data. I own that. But that over there, when I'm getting an element off the document, I don't really own that, do I? I didn't create it. I didn't create that. The browser created it for me. The browser is ultimately the one that's responsible for removing it. It's responsible for garbage collecting it. It's not inside of my function scope. I didn't create it inside of a function scope. I don't really own that data. I have access to it, but I don't own it. That's what we're talking about. If I don't own it, if somebody's passing it to me, then I should probably use a weak map. So this lets you attach data to objects you don't own. It's a little bit like a fingerprint, if you think about it. I've tried really hard to come up with analogies, and this is the best I can come up with. It's a little bit like, like the iPhone fingerprint reader. It lets you say something about, like, the phone is attached to me with my fingerprint, even though the phone does not own me. I have the ability to access the information there. It's memory safe. And here's where we're going to go start swimming in the deep end. It enables idempotent functions. That's a big fancy word. It's not scary, I promise. What does idempotent mean? I would love if everybody walked out of here feeling really comfortable with this word because it is really a game changer in the way that you can write your code. So let's talk briefly about idempotency. We've got a variable here, colors, and I have some made-up function, add colors. Now I'm going to call add color 3 times, and on these 3 different instances, what it's doing is just appending another value to my array. So I've got red, 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 and in the end, I have 3 values. That is not idempotent, right? Every time I called it, it continued to mutate the state. An idempotent function would allow me to call that infinite number of times, and as long as my arguments are the same, the output is the same as well. Nothing actually changes. These are great because they're safe to use all over your code. You can use them on like change handlers, event listeners, all kinds of places like that, and you can know safely I can call this function and my state's not going to get out of whack. Imagine if you had a validation on a form field and you wanted to add a validation message. Well, how can you say add the validation message? What if it's already on there, right? Well, if the function's idempotent, you can do that safely. Weak maps enable you to do this really easily. So here's a little example from Vue. If this is the reactivity core of Vue, and specifically we have the reactive function. So the reactive function in Vue, we don't need to go into the details about it, but we can see right here that it uses weak map. It's like one of the first lines in the entire page and the entire source code. So what that means is if I have an object, here's a simple object, A is 1, 2, 3, and then I've got, I try to create a reactive object out of this. I call it 2 times. Well, Vue is saying, Vue does not own A, 1, 2, 3 there. They don't own that object. So they used a weak map to reference it, and then they looked it up and said, hey, did somebody already create a reactive object out of this? Oh, they did? Great, just give them back the same exact object. So if you look, those are actually the exact same object between those 2 lines. Vue actually hands back the same object. So how could we use this? So here's a really simple example of how we could have idempotency for an event listener. Here we've got document add event listener on click, hello Earth, add event listener on click, hello Mars. I can call these as many times as I want on my document, and I'm going to add a new event listener every single time. Technically, add event listener is idempotent, but we're giving it a new function each time, so it's not acting that way. So what if we wanted to have an event listener like on click, where you could add it as many times as you want, and whatever the last callback you gave is the one that will actually get called. We can do that really easily with a weak map. So here I have a weak map in my module scope, which we just learned about, and then I'm exporting my function on click, and all we're doing then is seeing, hey, has the element that you're giving me to listen to the click for already been listened to? And if it has, in that case, then just go get the event listener for that and return it and call that whenever the click happens. So here, on every single time you call this function, we are going to set the value of that element's key to the callback that we want called. So if I call it 10 times, there's only ever going to be one function. So here we go. We were calling Earth 3 different times, and then we actually click, and it only does one operation. It only console logs Earth. Then I call on click 1 more time, I give it another handler, and this time it'll only log 1 time. So we're not duplicating the calls here. It's a single call. So the open source package that I maintain, AutoAnimate, is a single function. You import it into your project and you get this kind of behavior. So on the left is a list of next and nuxt. They're familiar sounding words, and if you try to sort them, you literally can't see what's happening because only one character changes. So with this one function, you can get that kind of animation, which is cool, kind of a story for another time. But the point is that what it's actually doing under the hood is it's an idempotent function. We know that those inputs are going to be animated, and then we use a lot of weak maps to track the state of the DOM elements that are in the function call. So that's weak maps. All right, next up is proxies. Proxies are Well, they're magic. And they enable magic, right? And something to think about here is, I heard magic was bad, right? Isn't magic bad? No, it's not bad. Magic's not bad. Don't worry about it. Magic is good. Magic in JavaScript is something we need to be careful about, and I'm not saying that we want to get overboard on this, but if you can provide somebody a much better API by having a little bit of magic in your system, it's not a bad thing. So let's figure out what that actually looks like. Proxies, yes, we're good to go. Technically, it doesn't support IE11. This is why Vue 3 does not support IE11, because they use proxies under the hood. But I think we're all willing to move past that now, hopefully. Okay, so what does it actually do? Okay, well, I've got this little object here, locations earth, and then I just say new proxy, and I pass the object into it, and it spits back another object, in this case data, and now I can access properties on it. Pretty simple, right? Nothing magic here, we're passing it into there, we console log. But why? What is the great value here? Aha, well, the great value is sitting in that little thing right there, right? That little object literal there is the second argument. Here's just a small sampling of what we could put inside of there. We could put a get, we could put a set. These are functions that will get called when somebody's trying to access those properties. And they will give you on a silver platter what property is trying to be accessed, on what object, and you can go do whatever you want here. So obviously this could be side effect heaven. You could do all kinds of naughty things that you shouldn't do. But you could also use this to create some really interesting experiences. There's a lot of other ones. We're gonna just focus on get and set right now because we're just learning what we need to go learn. These are all of the other things that you can put on there. So basically, anything that you can imagine you can do to an object, you guys can now intercept with a proxy. So here's a really, really basic example. Don't get scared, it's okay. Not too intimidating. We've got our proxy target, and we've got a get function. Our get function is doing this magic thing called reflect. I'm not gonna go into that, and frankly, I don't even really understand it, but basically what it does is whatever you were gonna do. So in this case, I'm getting the value, the same value that you normally would get from the object. We're doing it for you. But in this case, I'm actually going to modify the return statement. So I'm going to just go ahead and concatenate a nice little emoji there. And now when you console log data.locations, you don't just get earth, you actually get the little globe with it too. So the key concept here is that proxies are like middleware for objects. They're like middleware for objects. Imagine what you could do. Now, we're going to take a little dive here into the deep end, okay? Try to stick with me, because you'll get lost if you look down at your computer for too long. So the common use case here is to track dependencies. There's a lot of use cases, honestly. This is the one that you're going to see bubble its way into the common space the most often. So this is the simplest that I could manufacture of a dependency tracker. What do we mean by a dependency tracker? What properties is a given function trying to access when you call that function? So I've got a set right here, tracker, if you take a look, is a set. A set is just like an array, basically, with other cool things. It can do cool things like clear itself out, so you can't really do that very easily with an array, but a set can. What we're going to do here is we're going to clear the set out, and then we're going to call some user's function. Okay, let's take a look at the one that I came up with here. All it does is say, does data foobar equal earth? All right, that's the user function. And we're passing in the proxy. And then we're going to console log the value of the tracker on the other side of that. So what happened here is when foobar was accessed, our getter was called. Our getter said, somebody's trying to access this property. It threw it in the set. And then after the function call, we can examine what's inside of that set, and aha, we know that somebody inside of that function is trying to access the property foobar. Okay, I'm going to try. This is going to be crazy with all the technical stuff. I'm going to try a little demo here. All right, this is on CodePen. I suppose you could pull that URL out if you really wanted to. So this is a really simple form, and we're going to do some really simple validation on the form. I wouldn't recommend actually doing your validation this way. The intention is to show you how proxies work, not how form validation works. So I've got 3 inputs. When I type into those inputs, the values are going to automatically get assigned to form data. Form data is a proxy, okay? And then way down here, we are running all these validation rules that are in the validation rules array. So there's a validation rules array right here. We've only got one rule inside of here. It is accessing formdata.email, and if it has a value, it's returning true. Otherwise, it's returning an error message, okay? So I'm going to just type inside of here, and you can see it's automatically calling the value, or it's automatically clearing the value when I type into it. And the way that basically what it's doing is it's recalling that required function every single time there's a mutation. And it's doing that because it knows that you are trying to access the value.email. So like, let's create another one here. We'll do a confirm rule, and we're going to get some form data in here. And, whoops. And inside of here, let's just do a console log. And then down here, I'm going to add this. Okay, let's pull open our console real quick. And my expectation here would be that this would run one time, which it did. It's on 2 page loads. Okay, that thing ran one time. Now, if I start typing in here, I would expect to not see any more calls to that function. Why? That function didn't access anything from form data. So it should never be called. It's a dead rule. And our system, just by using a simple proxy, is smart enough to know it's a dead rule. I mean, there is not actually a lot of code right here. Like, that's the entire proxy. And it's already magic enough to know not to call that validation rule. Now, so what if I instead take my form data and I just console log form data.password? Okay. So it says undefined one time, and then it detects that, oh, the password has changed. Now, what happens if I type in my email? I get no console logs, because it's smart enough to know you didn't touch the email address, you touched the password. And there it is. So a validation rule for something like this could look like return form data.password is equal to form data.password confirm, and then we're going to return true. Otherwise, we're going to say not the same. Let that reload. All right, so we've got one error on our page right now. Email and password are required. Okay, we satisfied that. Now they're not the same. Now they are the same. And it knew to automatically call those functions just because the data we passed to it was a proxy. Hopefully that gives you an idea of some of the magic that's available to you down that path. The last thing to talk about here is tagged template literals. So template literals, you guys know these, right? Everybody's familiar with these? We use them every day. They're awesome. Life was harder before we had those. Can you use these? Yeah, pretty much. I mean, again, E11, you know, you can use them. But what about that? Okay, we just put some characters right in front of a tick mark. Well, it turns out that this is spec. This is how tag template literals work. We call that function a tag, and it automatically gets called with our value. In this case, I am just, you know, obnoxiously putting another emoji in front of it. And so now when I call, when I ask for this, it's actually modifying my string before it returns it. So here's my key concept for this. Tagged template literals are like middleware for strings. They let you do amazing things with strings. Here's the entire API spec for this. You have a tag, you get an array of strings, and then you get all of the expressions handed to you. This is unbelievably amazing. So every time that you use a curly brace, 1, 2, 3, 4, 5, 6, 7, 8, 9, all of those get passed in as the further arguments. So you can write it like this, which I think is a lot better. Here's like just an idea, right? Something you could do with this. Instead of writing console log, you could just write log, where log is a template literal tag. And in this case, it's going to call your function. You're going to console log just like you normally would. But what's this? We've just put a side effect inside of a console log very, very easily. That's going to maybe make an API request to send it back to your server and let you know that there's a problem or something like that, right? Very simple to do. Really powerful. How about creating DOM elements? This makes me sad. This is the spec that we've been left with for how you create DOM elements. It's unfortunate. It's true. It's what it is. It's incredibly procedural, very imperative. Well, what if we did a little bit of template literal magic? Okay, so I've got a tag here called DOM, and DOM just takes my value that's passed in here. It then takes all of them, joins them together, throws it into this DOM parser, parses it back out, and returns the body of the children. Now, if you're not familiar with DOM parser, don't worry about it. It's just a way to turn strings into DOM elements. But the end result here is it returns nice, fresh, clean DOM elements for me, and I can just append those to the body. This is pretty amazing, especially if you're in the context where you can't reach for something like React or Vue, like maybe, let's say, a web component. You're trying to write some web components. Inside of web components, if you guys have ever done it, you're on your own. You can use some really cool tools that are out there to do this, but basically it's up to you to know how to do it. Enter something cool like lit.html. This is one of the only tools that I know that actually uses tagged template literals. So I'll briefly show you what their API spec is here. You've got 2 functions, HTML and render, and you can basically give them any kind of HTML that you want inside of this tag template literal. They're going to basically do what we just did, give you back a function that's going to produce some clean DOM elements. Now notice that what they're giving you back here is actually a function. You can return anything you want to from these things. So in this case, a function, you call that function with the data that you want interpolated into your template, and it renders it back out. This is really, really cool. I think this is one of the most innovative and unique projects that I've seen in quite a while in the space. Oh, I have arrows to show you what I just said. There you go, thumbs up, it's good. All right, but what if we combined these 4 techniques? What would be possible? Well, it turns out this is possible. A land of unicorns and rainbows, beautiful green fields. I played around with this a little bit. Uh-oh. Oh, no. Oh, no. Unicorn land is gone. Huh? Come on, are you serious? Wow, that's obnoxious. Should I try unplugging it? Come on. No. Rock solid. All right. It's all right. I don't need the whole screen. Okay. All right. Here's Justin's crazy idea. So I've got 2 functions, R and T. I named them short because, you know, we get pretty quickly at developers the gist of what we need to type. Let's type less. All right, R and T here. So R just creates some reactive data. Location is Earth. T would be a template. Could look something like this. And inside of there, I have an expression. Now, notice one tiny little different thing about this expression is it's actually a function. There's no reason you can't do this. Guess what gets past the template literal when you do this? Your function. So now we have a function that's in scope of this HTML that we're rendering. So let's return a function that lets us mount it right on the page. Okay, so now we're going to mount something to the document element. You can see a facsimile of what that might look like. That's pretty cool. It's a lot like lit.html, I would say. I think the spec is pretty nice, but it's got a little trick up its sleeve. We can change the data, and it'll change the value. This is not using anything like React or Vue or Svelte. This is the techniques that we just talked about today through the course of this talk. It's just using some weak maps. It's using some proxies. It's using some module scoping. And it lets you create this kind of behavior where you don't even need these to create a reactive experience. Imagine if you could write a component like this. This is a pure function. It's not a React component that gets called 1,000 times. It gets called one time. And at the end, you could return a little template literal with your data. Imagine if your store was just that. You just had to return something. So I've got a little gift for you guys today. I actually wrote this up as a little package, and I'm going to release it as open source. It's released as open source right now. I launched it last night. It's 2 kilobytes, actually. Not 2 kilobytes like Preact is 3 kilobytes, which is actually 4 kilobytes, which doesn't include any of your JSX or your state management or anything. It's actually 2 kilobytes. There's no virtual DOM. We bind directly to the things that are on there. It has complete declarative rendering. There's no build tools whatsoever. You can import this anywhere you want. You can literally import it directly into CodePen and just start writing. And the knowledge is 100% transferable because everything we talked about and everything that's in this is transferable knowledge. It's just JavaScript. It's just JavaScript. I mean, React is just JavaScript too, I guess. All right, so let's take a little look here. Here's 2 URLs you guys are welcome to visit if you're interested. I would caveat this with it is experimental. Here's my little website for it. It kind of goes through the basics of what I just talked about. What I want to show you down here are just a couple examples to show you that you can actually build things in the real world with this. This isn't just pie in the sky. Here's a little calculator, 55 plus 3. This is all reactive. It's all using the techniques that we briefly talked about today. How fast is it? So here's Vue changing random values. There's 500 elements in here. It's changing them as fast as it can. Technically, it's on a 10 millisecond debounce to keep the computer from melting down. Okay. Here's Arrow doing the same work. It's really fast. It's fast because it doesn't need to do any virtual DOM comparisons whatsoever. When you mount those DOM elements, they are in scope of that little function you wrote. So it is fast. You can write actual reusable components. These are tiny little reusable components. You can select values. There's state associated with them. It's a nifty little thing. I hope you guys check it out. All right, that's my talk. I've got, thanks. Oh, go back. Leave those up there. I left some time for questions because I assumed there could be some. Yeah?
The proxy, and can it help with refactoring, like crappy tests?
It can. I mean, I do want to put some word of caution out there because it's easy to hide too much magic inside of a proxy. But if you have something like that R function where you're clearly defining, hey, I'm turning this into something, and now I understand that there's side effects associated with it, it absolutely can. We use them all the time on FormKit to be able to know things like when form states are changing, if a user is supposed to provide a validation function, we give them a proxy so that way we know what their data they're trying to access, and then they don't have to think about it. So yeah, absolutely. Yeah.
Regarding weak maps, it's like what you're saying, basically they're going to be holding on to any kind of memory that you don't own, whether that's the key value or keyword value, which is weak map.
Yes, if the key, so interestingly with weak maps, with maps, you can use a string as the key. With a weak map, you literally can't. It has to be an object. And so the object key is kind of the unlock there. Now, with DOM elements, I actually think this is somewhat intuitive because we, for a long time, have done really silly things like data attributes, where we put data attributes literally inside the DOM, in the rendered DOM, because we wanted to attach data to something. That's a perfect example of where weak maps could come in and save the day. Yeah.
So just to follow on that then, I guess, like if that's okay.
Absolutely, yeah.
If the key value is not like a string, I guess it's not a string, I guess a string in a sense. If it's not that, you can use that.
Yes. Not always, but yes. Weak maps, because they garbage collect the values, whenever you're accessing them, you need to know what you're about to access. Like, I need to go get that DOM element, or I need to go get something. So a map, for example, lets you iterate over the values because it knows they're in there. A weak map has no idea what's inside of it. So that's why it's good for attaching to something that's owned by somebody else. So if they give you something that they own, you can say something about it. So AutoAnimate, for example, it needs to track the x, y coordinates and the height and the width of every element that could get animated in the future. Well, that could be a bad memory problem, but it's not, because all we do is use the key of the DOM elements that are in the DOM as the key to know where the positions are. So it works great. Other questions? Yeah.
So you said weak maps enable idempotent operations.
Yes.
You basically opt into that like idempotency by choosing the set method instead of the add. Is that really?
Oh, great question. No. So add is for sets. The set method is how you address a map. Yeah. But interestingly, sets and weak sets, which are obviously equivalent but more akin to an array, they allow idempotency too, because if you add the same value, it automatically dedupes. In fact, if you go on Stack Overflow and say, how do I dedupe this array? What everybody tells you now is turn this into a set and then turn it back into array, which, by the way, is a very expensive operation. Any other questions? Yeah?
Is there a difference between using a tag template literal and just calling a function with a template literal as the argument?
Yeah. Yes. And the difference is that you're handed the expressions on the platter for you. So what the template literal does is it takes all of the strings that are in between wherever those $ curly braces are, and it takes all of those and it stacks them into an array. So you get a big stack of strings, and then you get n number of arguments, and all of those arguments are the expressions, the $ symbol-y pieces of that. And so you can then do whatever magic you want with it. Yeah. Yeah.
Is there anything to know about garbage collection with proxies? Like when you make a proxy, does that stop the reference object from being garbage?
That's a great question. Yes, it does. You gotta be careful with that. Anybody else? All right. Well, if you have any other questions, come ask me. Thank you all for coming by.